So in section 2.8, we have the transformation of the graph of a function. So we did talk about the function in chapter 2, okay? And we did a graph of function. We can graph a function. Now here, we will have a different type of transformation of a graph for a function. Okay, just let me take a function. So if I have a function f of x equals to square root of x. So this is a function, right? And how do we graph this function? So what do we need to graph a function? So we need the points, right? So for this function, what is our input? X, right? X is the input. And what is our output? F of x, right? And we can rewrite this as a y equal to square root of x. F of x and y, these two are the same thing. Now, in order to graph this, we need to have a table, right? We need a points to graph. So let's make a table. So we have an input x. Our output is f of x. Once we choose our input, we get the output f of x. And the input and output combined, we have a point. So our input is x coordinate, output f of x is the y coordinate. Okay, so this is the function we have. Now what kind of input we can choose for this function? Our function is a square root function. Are we allowed to choose any real number for this function? 0 or greater, right? So we can't choose negative number, okay, but we can choose 0. So if our input is 0, what is the output? Square root of 0 is 0, right? So we have 0, 0, 1 point. Now we can choose 1. So if input is 1, square root of 1 is 1, so we have 1, 1. Okay, we can choose 2, 3, or like 2.5. Okay, you can choose any number which is greater than 0, but let me go ahead and choose 4. So if input is 4, what will be our output? Square root of 4 is 2, right? So we have 4, 2. Let me choose 9. Excuse me. Then square root of 9 is 3, so we have 9, 3. And let me choose 16. Excuse me. So we have 4. So this is 16, 4. Okay, now can you graph this function? Can we graph now? What do we do to graph this function? Okay, just let me give you a 2-minute time, okay? I'll be right back. I want you to graph this, okay? Okay, let's go ahead and graph this function. So in order to graph, we need our x-axis, we need y-axis. So this is origin. So 0, 0, so we have 0, 0. So this is 1, this is 1. So we have 1, 1. This is 2. This is 4. So we have 2, 4, 2, 4. Then we have, we don't have 2, 4, sorry. The next point is 4, 2, right? Okay. So this is, so 2, 3, 4. This is 2, 3. So we have 4, 2. The next point is 4, 2. So let's plot this one. So we have 4 and 2 here. Then we have 9, 3. Let's say this is 9. We have 3 and 16, 4. So we have 16 here. Let's say this is 16, and we have 16, 4. Okay. Right. So if we connect every dots, we get a graph. Okay. How far can we extend this graph on the right? Yes, right. We can choose any number which is greater than 0, right? Now this is the graph for this square root function. Now in this section, there are some of the very basic function, and you need to know the graph. You can just make a table and you can just plot a graph by yourself, or you at least you need to know the shape of the graph on the basis of a type of a function. Okay. Now I'm gonna erase this one. I need to have this space here. So do you have any question on graphing a function? Okay, now let me erase this one. Now we have the function, very basic function, okay, and their graph. So if our function is linear, let me say our function f of x is equals to x. What kind of function is this? Linear function. And if it is a linear function, what is the shape of a graph? What kind of graph do we get? Straight line. Okay. So for this linear function, our graph is straight line. Now this line passes through the origin. Okay. So this is the graph for this linear function. So whenever you have a linear function, the graph is straight line. Okay. So let's take a different function. So if our function f of x is equals to x squared, now what kind of function is this? Is this a linear function? Is it linear or not? The first one is linear, okay? So this is our linear function. So this is our linear function. Now if we compare, these two are not same, right? First is linear, but second is quadratic or square function. Okay, and if you have a square function or if you have a quadratic function, the graph of the function is parabola. Okay, so like U shape. So we can have U shape graph. So if you have a square function or if you have a quadratic function, your graph is always parabola. Okay, so this is the second basic function. The next function, we have a f of x equals to square root of x. This is our square root function, and we had a graph earlier, and the graph of the square root function is, so it can have 0 and the graph goes all the way to the positive infinity. So this is the square root square root function, graph for a square root function. Next, if our function f of x equals to absolute value of x, what is the name of this function? What? Any guess? The name. So we have f of x equals absolute value function. Yeah, this is absolute value function. Okay, and the graph of this function is v shape. Okay. Now if we plot a graph for this function, we get a V shape. If we say square root, so if we say square, we're going to have a U shape. If we say absolute value function, then we always get a V shape function. Okay. The next, if we have f of x equals to x cube, can you guess the name for this kind of function? What would be the name of this kind of function? Cubic function. Okay. So if we have a cubic function, this is our cubic function, and the graph of a cubic function is like this. Okay. So this is a graph for a cubic function. So I want you to know the shape of the graph for each kind of a function. Okay. Next, let's take our function f of x equals to 1 over x. What would be the name for this type of a function? Rational function. Okay. Any other name for this function? So if you have an x, what is 1 over x called? So you have a number x, okay, and what is 1 over x for that x? Okay, if you have a 2, and what is 1 over 2 for a 2? Like, what do we call that? Those two. It's a rational, that's correct. Reciprocal? Have you heard the reciprocal? You just switch the numerator and denominator, right? So this is you can call rational function. It's a rational function or reciprocal function. And if we graph this function, the graph of this reciprocal function or the rational function is like this, okay? And one more, the last one, okay, so if our function f of x equals cube root of x, the graph of this function is okay, this is the graph for a cube root function. Now you can get the graph for each function by making a table and plotting a points, okay? So you can just go by that way. But if you know the shape of this type of function, then it will be easy for this section, okay? So basically we'll be talking about this different kind of a function, and with the help of this basic function, we will graph a more complex function. So we use this graph. Okay, these are the graph for the very basic function, and with the help of this graph we will graph the more complex graph. Okay, so you should know the shape of this graph, and if you have a graphing calculator, you can use your graphing calculator to graph this basic function. If you don't have, you can use the table. You can just make a table, plot the points, and you can get the graph. Okay, or if not, if you know the shape, if you can memorize the shape, it will be the very quick. If not, you can always use a graphing calculator, or you can always use a table and a plot of points to get the graph of this function. Now, so let me go to this example here, then I'll just describe what we have here. So here we have our f of x equals to absolute value of x. Now what kind of function is this? It's an absolute value function, right? Now if we go back, now here we have the graph for this absolute value function. So this is a graph, so let's redraw that. So we have a graph here. So absolute value of function is always V shape, okay? So we have a V shape. So this is our f of x equals to absolute value of x. Now, with the help of this basic function, we need to graph absolute value of x minus 2. Okay, now once you know the basic graph, you don't need to use a graphing calculator, you don't need to use the table but you have to know the basic graph. Okay, you need to know what is the shape of a basic function. Okay, so this is our graph for a basic function. Now we are trying to graph our g of x with the help of this basic function. Now if we compare these two functions, what difference do you find? So if you compare your f of x and g of x, what is the difference here? So what is the difference do we find here? Okay, the range is different. How can you say that?
Because it goes down to negative.
Okay, that's correct. Now forget about dominant range, that's correct. But if you just compare here, now for f we have g, right? So f, g are just the name of a function. And on the output, we have an absolute value of x here, we have an absolute value of x, and we have like a negative 2 extra, right? So 2 has been subtracted from this function f of x. So if we subtract 2 from f of x, we get g of x. Do you agree with that? So our f of x is, so f of x is absolute value of x, and if we subtract 2 from this f of x, if we subtract 2 from this f of x, we get our g of x function. Our g of x is absolute value of x minus 2. That's what we have here. Okay, so we subtracted 2 from our basic function. Now what does that mean for this graph? So what happens when we subtract 2 from the function f of x? Okay, just let me give you time, and just can you just graph this for a while using a table, or like a, if you have a graphing calculator, graph this g of x, okay? Okay, just go ahead and graph this g of x, okay? You can use a table or calculator if you have any. And compare the graph for the f of x and g of x. Okay, like what differences do we find? Did anyone have a graph for the g of x? You can use a, if you have a graphing calculator, you can use it, or if not, we can just make a table and plot these points. Eliza, do you feel good now? Did anyone get a graph for this function? Anyone else? Okay. Now, if we compare two graphs, what differences do you find? If you have the graph, the graph is shifted down by 2 units, right? So when you plot a graph for this function, so the graph that we're gonna get is that we're gonna get the exact same graph, but the graph is shifted down by 2 units. So we have, let's say this is -1, -2. The graph for our g of x is, we're gonna get the same graph. The only difference is that this graph, okay, so this is the graph for the basic function, And when we subtract a number, we have a 2 here, we subtracted 2. The graph has shifted down by 2 units. So from here we can make a general statement. So you have a basic function, and if you subtract any number from that function, your graph is always shifted down. Okay? So here we subtracted 2, it means the graph shifts down by 2 units. If you subtract 10, the graph shifts down by 10 units. Okay? Now, once you know the graph of this basic function, since 2 has been subtracted, you just shift the same graph vertically down by 2 units. You don't need to make a table. Okay? You can shift this graph vertically down by 2 units if you subtract any number from the function. Okay? Now, for the same function, what happens? Okay, let me take a different function, h of x. And h of x is absolute value of x plus 4. Now, we still have an absolute value function, right? So we still have absolute value. This is the absolute value function. Now, if we compare this absolute value function with this basic absolute value function, what difference do we have? 4 has been added, right? So if you add 4 to your basic function, we get this h of x. And what happens to the graph? Can you give a guess here? When we subtract, the graph goes down. Now what would be the case when we add a number to a function? The graph moves up. It is shifted vertically up by how many units? By like whatever number you added. 4. So the graph is shifted vertically up by 4 units. Now I can draw a graph for this function from this basic. So this is the graph for the basic function. Okay. So let me just redraw that basic function. Okay. So this is our basic function. And the 4 has been added. So this graph is shifted vertically up by 4 units. So let's say this is 4. So we have this graph. This graph. Okay, these two are the same graph. The only difference is that this basic graph has been shifted by 4 units, and this graph is a graph for this h of x. So whenever we add a number to a function, the graph is shifted up by vertically up. When you subtract a number, the graph is shifted vertically down. Okay. Let me take a different function here. Okay, let's say we have f of x equals to square root x negative 4. Now, for this function, what kind of function is this? A square root function. Now, this is a square root function. We have to know the graph of a basic square root function. Okay, our basic function is. So basic square root function is, that's what we had earlier. So basic square root function is f of x equals to square root of x. Now let's draw a graph for this function. You don't need to be precisely correct. Okay? You can just have like a close enough. So the graph of this function looks like this, right? That's what we know. So this is the graph of a basic function. You have to know this one. Now, once you know the graph of a basic function, we compare our basic function with the function given to us. Our target is graphing this function. We are graphing square root of x minus 4. Okay? And we are using our basic function graph concept here. Now, if you compare basic function and this given function, what is the difference? 4 has been subtracted, right? So 4 subtracted. Now, when we subtract a number from a function, what happens to the graph? The graph is shifted vertically down by how many units? 4 units. Now let's shift this graph down by 4 units. So this is 0, negative 1, negative 2, negative 3, negative 4. Okay, we draw a similar graph from negative 4. And this is our f of x equals to square root of x minus 4. And this is our f of x equals to square root of x. So when we subtract a number from a function, we shift our graph vertically down. When we add a number, we shift our graph vertically up. So this is the one transformation. Okay, so once you know the basic function, and if there is any number added or subtracted, you can use this concept and have a final graph. Okay, you are not required a table here. Okay, once you know this basic graph for a function, you can always graph your other function with the help of this transformation. Okay, now so before this one, so let me do one more similar. Okay, now let me take a different function. F of x equals to x cubed plus 5. Now what kind of function is this? Cubic function. Okay, so we need to know the graph for a basic cubic function. So our basic function is y equals to x cubed, or you can use f of x. So this is our basic function, and the graph for this function is, so this is the graph for the cubic function. So you have to identify the basic function for the given function. Okay, that's the very key thing. And once you have the basic function, you should know the graph for that basic function. Now we compare this basic function with the function that we are asked to graph. So this is the function that we need to graph here, x cubed plus 5. Now if we compare with the basic function, what has been done there? 5 is added, right? So if you add 5 to your basic function, we get the function f of x. And what does it mean by adding 5? What happens to our graph? The graph is shifted vertically up by 5 units. Now we're gonna shift the same graph vertically up by 5 units. So 1, 2, 3, 4, 5. Okay, so we're gonna shift this graph vertically up by 5 units. So you shift the graph vertically up by 5 units, and this graph is our f of x. F of x equals to x cubed plus 5. You add a number, you shift a graph up. You subtract a number, you shift your graph vertically down. Okay, so this is the one transformation. Okay, the next here. Okay, now, so here we have this absolute value function. We know the graph of this function. Okay, so the graph of this function looks like this, V shape. Now our target is graphing g of x with the help of f of x. Now what is the difference here? Let's find the difference in the output here. We have the absolute value of x, we have absolute value of x minus 2. Now how can we get x minus absolute value of x minus 2 from absolute value of x? What is the difference? Yes.
Goes right.
Okay, that's correct. Now here, okay, now our basic function is f of x equals to absolute value of x. This is our basic function. Now if we subtract 2 from this function, do we get g of x? So subtracting 2 means, so if we subtract 2, are these two same, like g of x and f of x, are these two same or are different? It's a different. Okay, that's correct. Now how can we get this g of x from this basic function absolute value of x? Like, what do we need to do? Do we have to add a number? Do we have to subtract a number? Or do we have to make a replacement here? Now here, if we compare these two, if we replace x of a basic function by x minus 2, do we get g of x? So we have this basic function, okay? We have this basic function, and from this basic function, if we replace x of a basic function by x minus 2, so we replace x of a basic function by x minus 2. Let's see what happens. We have f of x minus 2 equals to absolute value of x minus 2, and absolute value of x minus 2 is same as g of x. Do you agree this one or not? Like if we replace x of a basic function by x minus 2, we get g of x. Now what does it mean? Now what happens to a graph when we replace our x of a function by x minus some number? And here is the thing. Now when we replace our x of a function, okay, so when you replace, earlier we added a number or we subtracted a number. Now here we are replacing x of a function by x minus some number, okay? It can be x minus 3, x minus 4, x minus some number. Now if we replace x of a function, basic function, by x minus some number, in this case we have x minus 2, then the graph is shifted horizontally right by 2 units. Now we shift this graph, same graph, on the right, horizontally right by 2 units. So this is 1, this is 2. So we shift the graph on the right by 2 units. And this is a graph for our g of x function. So whenever we replace x of a basic function, okay, so this is our basic function, and if you replace this x of a basic function by x minus 2, then the graph is shifted horizontally right by 2 units. If you replace by x minus 10, then the graph is shifted horizontally right by how many units? By 10 units. Okay. Now, similarly, if we have, okay, let me take different function. H of x equals to absolute value of x plus 3. Now, this is our new function. This is the absolute value function. So the basic function is f of x equals to absolute value of x. This is the basic function. Now, how can we get h of x from our basic function? What do we have to do? Do we have to add a number? Do we have to subtract a number? Or do we have to make a replacement here? How can we get this h of x function from this basic function? We make replacement. So we replace our x of this basic function by x plus 3. Now what happens to the graph? So this is a graph for a basic function. We already have a graph for a basic function. Okay, so this is our y equals to absolute value of x. And when you replace, okay, x of a function by x plus some number. So here, so we replace x of a function by x plus some number. In this case, we are using 3. So if we replace x of a function by x plus some number, then what happens to the graph? Where do you think the graph will shift? Left, right, down, up? It will shift left by how many units? By 3 units. So the basic graph is, this is the basic graph, okay? So is here, now it's shifted on the left. So this is -1, -2, -3. So we shift our basic graph 3 unit on the left. So this is the graph for our h of x. Okay, so when you replace x by x minus some number, you are shifting on the right. If you replace x by x plus some number, you are shifting on the left. Okay, if you add a number to a function, you are shifting up. If you subtract a number from a function, you are shifting down. Okay, now with this here, let me go to an example here. Okay, So let's draw a graph for a function. So let's say our function is f of x equals x plus 1 square negative 4. Now, once you are asked to graph, the very first thing you have to know what is the basic function corresponding to this function. Now, what kind of function is this? Okay, do you all agree it's a quadratic function? If it's a quadratic function, what is our basic function? So basic function is, our basic function is, y or f of x is equals to x square. This is our basic function, right? Or I can just use f of x. Okay, so f of x equals x square. This is the basic function. Now, does anyone need help finding the basic function? You have a function, and once you know the type of a function, you can just find the basic function. Okay, now once we have the basic function, we draw a graph for this basic function. We know the graph of this basic function. The graph of this basic function is this one. This is a graph for a basic function. Our target is graphing this function. Okay, what we know? We need the graph of this basic function. Now, here is the thing. Now, how can we get, okay, we are trying to get x plus 1 square minus 4 from this x square. Now, this is what we have. We have x square. Okay, this is what we have. And we need to get x plus 1 whole square minus 4. You are allowed to add a number. You are allowed to subtract a number. And you are allowed to replace x of a function. Okay, now, let's compare these two things. So what we need to do here to get this x plus 1 whole square minus 4 from x square, what do we need to do? Okay, that's the final results. Okay, now let's go step by step. Now here, if we compare these two, for square we have square, right? For x, what do we have? X plus 1. Now how can we get x plus 1 for x? What do we have to do? We have to replace, right? So if we replace x of this basic function by x plus 1, we get this expression. So at first, so let's replace x of this function, replace x of a basic function by x plus 1. Now let's see what happens. So we have f of x equals, so for this x, we have x plus 1. X plus 1 and square. Now, if you are replacing x of a function by x plus 1, the graph does not remain same. It has to change, right? So what happens to this graph? Where it goes? We are replacing x of a function by x plus a number. What happens to this graph? It shifts horizontally or vertically? Horizontally, right or left? Left. Okay. By how many unit? 1 unit. Okay. So this graph is shifted on the left horizontally by 1 unit. Now let's shift this graph 1 unit left. So we have -1 here. And let's draw a similar graph here. So we have this graph. Okay. So the graph has been shifted 1 unit left after replacing x by x plus 1. Okay. Now, this is our target. We want to get x plus 1 square minus 4. So we are here. Now what do we need? So if we compare x plus 1 square and this expression, what is missing? -4 is missing, right? And how do we get -4? We have to subtract -4. So let's subtract -4 from a function. Subtract 4 or add -4. Okay, so if you subtract 4, our f of x equals x plus 1 square -4. Now what happens to the graph? So when we subtract a number from a function, what happens to the graph? It is shifted vertically down by how many units? 4 units, okay? So this is -1, -2, -3, -4. Now which graph do we shift? This one or first one or the second one? Second one, right? We are at second. So we shift our second graph vertically down by 4 units. So this is our final graph. So this is the graph for our function x plus 1 is square minus 4. Okay, let me know if you have a question here. So once we have the idea of a transformation, it's very easy to graph, okay? And you can check this final graph using your graphing calculator. Okay, you can always graph of using your graphing calculator. But if you are asked to graph this function, then at least you have to mention what is the basic function. Okay, you have to have the graph for a basic function. Then we have to show every transformation. Okay, at first we replace x by x plus 1. Replacing x by x plus 1 means you are shifting this graph on the left by 1 unit. Then we subtracted 4. Subtracting 4 means you are shifting this graph vertically down by 4 units. So this is our final graph. Okay. Let's do one more. Okay, then we'll be done for today. Okay. So let me choose our function g of x equals okay, so we have x plus x minus 3 cube plus 5. So we need to graph this function here, g of x function, which is x minus 3 cube plus 5. The very first thing, what kind of function is this? So we had like a 6 basic function, right? 6 or 7. Okay, if we go back on the very first page here, so we have 1, 2, 3, 4, 5, 6, 7. Okay, so out of 7 function, what kind of function is this here? Cubic function. So if this is a cubic function, what is the basic function? What is the basic cubic function? X cube, right? So basic cubic function is you have a g of x. You can use g of x, or you can just write f of x. It's x cube. Both of these are cubic functions. It means both of these gonna have similar graph, not exactly same. Okay, both of these are a cubic function, so they're gonna have a similar graph. So let's draw our cubic function graph for this basic cubic function. So if you don't know the shape of the graph, you have to use the table, or you have to use the graphing calculator. But we know the graph of the cubic function. So every cubic function looks like this. Okay, so this is our cubic function. So once you have the graph of a cubic function, so you have the basic function, and from basic function you have to get the function that you are given. Now how can we get, or what we have to do to get x minus 3 cubed plus 5 from x cubed? So we have x cubed. Now what should we do here? So what are the steps here? So we replace x by x minus 3. Okay, so we replace, now we are working on a basic function. Okay, so we replace x of a basic function by x minus 3, because you are given x minus 3 here. That's what we use to replace. So our basic function is f of x equals x minus 3 cubed. And what does it mean? What for the graph when you replace x by x minus 3? Where it goes?
For example, in 3.
The graph is shifted horizontally, right or left? Right by how many units? 3 units. So let's shift this graph on the right by 3 units. 1, 2, 3. Okay. So we draw a graph, similar graph at 3. So this is the graph. We shifted 3 units on the right. So here we already have x minus 3 cube. That's what we have. And we need a plus 5. It means we need to add 5 to this function. So we add 5. And after we add 5, our f of x is x minus 3 cube plus 5. Now, what happens to the graph when you add a number? The graph is shifted vertically up by how many units? 5 units. Okay, let me use a different color here. So we have this red graph. Now we shift this red graph vertically up by 5 units. So 1, 2, 3, 4, 5. Okay, so we're gonna shift this graph vertically up by 5 units. So this is the final graph, f of x. And these are the two transformation that we did today, okay? Horizontal shift and vertical shift. And remaining we will do in our tomorrow's class, okay? So let's do this much for today. If you have any question, let me know. I'll be here for